السلام عليكم ورحمة الله وبركاته والصلاة والسلام على سيدنا محمد وآله وصحبه أجمعين. In this video, we'll discuss the definition for acid and base and how to classify substances to acid and base according to Bronsted and Lowry model. So, what is acid and base according to Bronsted and Lowry model? Okay, so according to Bronsted and Lowry, the acid will be a proton donor and the base will be a proton acceptor. So what is the meaning of proton donor? Proton donor is the hydrogen plus ion. So this is the substance can donate hydrogen plus, it will be considered as Bronsted acid. And the substance that can take the hydrogen, so this will be considered as Bronsted-Lowry base. Let's see an example. So we will have an equation. So to see which one can donate, which one can take or accept, so we need to put it with another one, with another substance. So most of the time we will take it with or write it with H2O, so HF plus H2O. So for this equation, we will have the products like this. So now from the equation, we need to check which one took the hydrogen, which one donates the hydrogen. Okay, so HF, we change it from HF to F minus. So it means this one lose the hydrogen. So this is the one who donates the hydrogen. And of course, he would donate it to give the hydrogen to the other substance in the reaction, which is H2O. So now the proton, which is H plus, we will go for H2O and attract or combine with the H2O to form H3O plus. So if HF is going to give the hydrogen, so this would be considered as Bronsted acid. H2O taking the hydrogen, so it would be considered as base. Before we go deep for acid and base, Bronsted and Lowry, so why H2O will take the hydrogen or the proton? Because we know that for oxygen, it has two lone pairs of electrons. Here they are free. It means it can attract the hydrogen or the H plus moga, because here this one will be need to attract or bonded with electron because it needs electrons. So the one which has free electrons, this one can attract the proton or the H plus. Okay, so this will be an acid according to Bronsted-Lowry, and H2O will be a base. Let's see another one. If we have an H3 plus H2O, okay, the equation will be completely like that. NH4 plus OH minus. So here, as we will see, NH3 converted to NH4. Actually, it means this one, the hydrogen here, it's increased. It was 3 before the reaction, and after reaction, now it's 4. It means this one, or NH3, it's gained hydrogen, and it's gained a proton, or H plus, and it will gain it from H2O. So it means H2O here will lose the hydrogen. So if we will just examine H2O, when it will be ionized, it will give H plus and OH minus. So it means it will losing the hydrogen plus to give it to NH3, and then we will have the OH minus. So NH3 now is the acceptor for the proton, so this will be a base, and H2O will be an acid. Okay, another one, HCOO, H plus H2O. The equation will be HCOO minus plus H3O plus. Okay, so now again, you need to examine which one gives the proton, which one takes one. So as we see here, this one, it was HCOOH, and after the reaction, HCOO minus. So this one lost one hydrogen. So the proton here, or the H plus, we will go from this substance to H2O. So this one will be an acid, and this one will be a base. So we can classify the substances according to Bronsted and Lowry to acid and base, according to which one will donate the proton, which one will take the proton. The last example, CO3 2 minus plus H2O. Okay, let's see this one if we can complete the equation. So we will examine the first one. Does it contain any hydrogen or any proton to give? Actually, it's not. It doesn't contain any hydrogen here. So it means this one needs a proton, this one needs a hydrogen. So you need to take from hydrogen or proton from H2O and give it to this one. So it will be HCO3. So you're adding hydrogen to this one. Okay, what about the charge? It was -2 and now +1. So it was -2 and you're adding to it +1. So you need to add the charges. It will be +1. -2 plus 1, so it will be -1. Plus, we said before that H2O is just H plus and OH minus. So this H plus will go for the CO3. So we will end by OH minus. So CO3 will be a base, and H2O will be an acid. Okay, so before we develop, what is the acid again, and what is the base according to a base, according to Bronsted and Lowry? So the acid which substance can donate H plus, okay, or give H plus, and this one, which one accept or take the proton. Okay, if you are having an acid with acting with H2O, say that we will take both of them with H2O. So if this one will donate the hydrogen to H2O, so in the equation you will find H plus, which will be expressed at hydronium ion H3O plus. So if you can't find this one as a product, so one of the products will be H plus or H3O plus, which is called hydronium ion. Okay, and if it's a base, you will find OH minus in the equation as a product. So if it's a base, you will find OH minus as a product, and if it's an acid, you will find hydronium ion. And again, what is hydronium ion? H3O, it's just H plus with H2O. This will combine and give you the hydronium ion. And if you have hydronium ion, it means this substance contains proton or H plus, so it's an acid. Okay. If you want to complete the equation between H2O and any other substance, let's say HA, okay, and if you want to complete the equation here, so we need to check this one. If this one has a hydrogen at the beginning, okay, so this one is a proton donor, so it will give the proton to H2O, so this one will be an acid. Or if it's an organic one, sometimes the organic compound like a CH3, let's write it in the formula, CH3COOH, which is acetic acid. This one could be written like HC2O2H3. So it could be written like this, or HC2H3O2. Sorry. Okay, so it could be written like these two ways. So if you know the formula of the organic compound, you find organic acid, it means you will be with hydrogen, with carbon and oxygen. So the first one is, this is the hydrogen for the functional group. This one will be lost to H2O. Or you can find it like this, and this is the function group COOH for the organic compound. So the last hydrogen will be lost to H2O. And never take the hydrogen from the carbon, okay? This one will be never lost by this compound. This is not the acidity one here, okay? So you will take the hydrogen with the functional group, which will be written with oxygen next to oxygen, or in the front if it will be written like this. If we have an equation like A minus plus H2O, so we will know in this case we don't have an hydrogen, so the hydrogen should be moved from H2O to this one to be attract the negative charge. And if we have an H3 plus H2O, we know that the nitrogen has lone pair. So in this case, the nitrogen can attract the hydrogen from H2O, and this will be a base also. But sometimes in H could be an acid, like if it will be like NH4 plus. So if it contains 4 plus, if it contains a positive charge, it means it has more protons. So it can donate the proton, the excess ones that she had. Okay, so this excess proton will go from the NH4 to the H plus. And in this case, this one will be an acid, not a base. So it will be a base if it's NH3, or NH2 minus if it contains a negative charge. So if it contains a negative charge or with no charge, it can act as a base because it can attract the hydrogen because it has lone pair. But if it contains plus or positive sign like this one, it means it has more protons, so it will give the hydrogen. And after giving that, it will convert it to NH3 plus H3O plus. Okay. Now, if we want to continue for acid and base for Bronsted and Lowry, let's go back here for this one, for the first one. When we check this acid and base, Bronsted Lowry acid and base, we will see that HF was an acid and he gives the proton to H2O and then convert it to F minus. So this F minus will never appear if the HF can't lose the hydrogen. So it will only appear if the HF will lose the hydrogen. So it will be just like the other phase for HF. So HF has double phase. The first one, which should be an acid, and after losing this hydrogen, this acidity, it will convert it to F. So now he losing the acidity, so he will be a base. And we will call it a conjugate base. So the conjugate base just like the other phase for the acid after losing the hydrogen. And H2 was a base, but it will convert it to H3O plus, and this is the other phase for the base, so it will be the opposite, it will be the acid phase. Okay, but we will call it conjugate. Okay, this would be as a conjugate for. So according to Bronsted lowry, we have a conjugate pair for each equation. So for each equation, we have two pairs. The first one, which is acid and the conjugate base. The second pair, it will be a base and a conjugate acid. Okay, let's take here one more example. So for this one, we said that HCOO will an acid because it will lose the hydrogen to H2O. So what is the other structure? What is the other phase for HCOOH after losing the hydrogen? This one. So this one will be a conjugate what? Conjugate base, because this is the other phase here. And for H3O, it will be the other phase for H2O. So this will be a conjugate acid. So in this equation, we have two pairs. The first conjugate pair will be HCOOH and HCOO. This is the first pair as acid base pair, and the second pair will be H2O with H3O. So we have two pairs here, conjugate acid pair in each equation. So according to Bronsted and Lowry, in each equation we have two pairs, acid and base conjugate pair. If you want to write the conjugate acid base without writing the equation, so we could identify the acid base conjugate with the equation, but if you want to write it without writing the equation, could we do it here? Actually, yeah, we could write the acid and base conjugate pair without writing the equation. Okay, let's see an example how to write them. Okay, so if you want to write the conjugate acid, and if you want to write the conjugate base. If you want to write the conjugate acid, so we will add proton to the substance. So this will be the conjugate acid for this one. If you want to write the conjugate base for any substance, so we will remove proton. So let's see an example. If we have S2 minus and we want to write the conjugate acid for this one, so we will adding proton, we're adding H. So it will be HS, and we need to add the charges -2 + 1, so it will be -1. So this is the conjugate pair here. If we're having H or H minus, and we want to write the conjugate acid for this one, so we will adding proton H, so it will be H2O, and the positive and negative will be 0, no charge. If we have HSO4 minus, and we want the conjugate acid for this one, so it will be H2SO4. We will do the same if we want to write the conjugate base, but it will be the opposite way. We will need to remove a hydrogen. So if we have H2CO3 and we need the conjugate base, so we will remove one H, it will be HCO3, and don't forget the charge because it will be -1, it will be removing a +1, so it will be -1. And if we're having NH4, what is the conjugate pair for this one? So remove one of the protons, so it will be NH3, and so on. So you can write the conjugate as a conjugate base without writing the equation. Okay, let's complete this. We have an equation here. We need to complete this equation, and after completing the equations, we need to identify the pairs inside each one. Okay, so for the first one, O2 minus with H2O. If this one doesn't contain any hydrogen, so it can't give the hydrogen, so it needs to take the proton from the H2O. So the proton will go from H2O to O minus, so it will be OH minus because we're adding -2 + 1. Plus, we said before that the H2O is H plus with OH minus. So if you remove this one, so we will end with OH minus. So again, need to classify them. O2 minus is just taking the proton, so this will be a base, and H2O will be an acid. Okay, so OH will be a conjugate acid, and this will be a conjugate base. Okay, the second one, CH3COOH, again, it's written, this is the functional group for the organic acid, so it will be losing the hydrogen, which was the functional group, this one, so this hydrogen will be go for the H minus, and we have here HS minus, and if it contains minus, it means can attract CH plus, so it will convert it to CH3COO minus, because we're losing one positive, and H2S. This one will be the acid, this one will be the base. Okay, this will be the conjugate base, and this one will be the conjugate acid. Okay, the last one, NO2 minus and H2O. So NO2 minus has no hydrogens. It will take the hydrogen from H2O. So it will be HNO2 plus OH minus. So this will be base, and this will be an acid. This is a conjugate acid, and this is a conjugate base. Okay, before you finish, you need to check. You started with a base, so we have OH. Start with an acid, so we have, oh, this was not it, no, H2O, so we don't have H3O. So we started here with a base, so we have OH. So if you start with a substance with H2O, you can check your work, you will find in the product OH if it's a base, or H3O if it's an acid. Let's take one more where the H2O will act as a base, like H2S plus H2O. So we'll see that this one will give the hydrogen to H2O, so it will be H minus plus H3O. So this one will be an acid, this one will be a base, here the conjugate base, and this one is the conjugate acid. Okay, so here you are with H2O, an acid with H2O, so we will find the hydronium ion in the solution. If it's a base with H2O, you will find OH in the solution. As you can see here, we have H2O that can be act as here in this case. H2O is an acid and H2O as a base. So we have H2O can act as base and acid at the same time. This will be called amphoteric substance. So the amphoteric, sorry, the color. Amphoteric substance is a substance that can act as both acid and base, Bronsted acid and Bronsted base. So the amphoteric substance is a substance that can act as an acid and base at the same time. Okay, thank you, and see you in other videos.